So for the rest of the session, I'm going to give you an introduction to confidential computing, and I'm going to keep this quite brief because in about 2 hours, Mark Rossini is going to give a keynote and a great introduction to confidential computing. And so I'll keep this brief, and I'll focus more on what I see as challenges and opportunities that we have as a community and as an industry. And I'm excited to announce that at the end of the session, I'll announce our new product launch, our first commercial product. So stay tuned. So let's start with the problem that confidential computing is solving. As you may know, some infrastructures, for example, the cloud, is just not trustworthy enough for certain workloads. And today, you're essentially just giving your workload, your code, your data to the cloud provider, and you hope for the best. You hope that everything is run as intended and that there are no threats or leaks in the infrastructure. And of course, this works out for many workloads, but it's unsatisfactory for some other workloads. And this is where confidential computing comes into play. It takes you from this rather messy place to this great new place where you have your own secure carve-out in the cloud that is isolated from the rest of the infrastructure, that's runtime encrypted, and that is even verifiable. So you know precisely what's going on. And it's a bit like having your own on-prem running on the cloud. And this, sounds almost like magic, and at least when I heard about it for the first time, like almost 10 years ago, it certainly felt like magic. And now the question is, how does this work? And let's take a look at how this works from a technical perspective. And the idea is to consider most components in a typical hardware-software stack as untrustworthy or not trusted. And now, the only really trusted component here is the CPU. And the CPU can build what is called an enclave around our sensitive workloads. For example, our app or a single function. Essentially, you can load any data and code into an enclave. And this enclave now has some interesting properties, 4 properties to be precise. The first one is isolation. So the CPU takes care to isolate your enclave strongly from the rest of the system. And this includes the operating system and the hypervisor. They cannot access an enclave. The second important property, this is what many people find particularly exciting, is that the CPU ensures that all the code and data remains encrypted at runtime in memory. And the third feature, which I find super exciting or maybe even more exciting, is remote attestation. And this means that the CPU can issue a certificate for your enclave from which I can infer that the enclave is precisely running my workload in the intended way with the intended configuration on some good and trustworthy CPU. And the fourth property is sealing. And this is also a property that's provided by the CPU, and it allows an enclave to securely keep state between invocations, even on an untrustworthy environment. Yeah, and the most important feature here is arguably remote attestation. Without remote attestation, everything falls apart. But they only work really together as a whole, the 4 properties. And Intel pioneered this. They started talking about it in 2013, shipped it in their first CPUs in 2015. And then, a couple of years later, AMD came out with a new technology called SEV. And they essentially took the enclave concept and extended it to full virtual machines. So now you had confidential VMs. And they have essentially the same properties as secure enclaves, but they're easier to use because you have a full operating system inside your secure execution environment. Currently, this is only available in AMD CPUs, but Intel and ARM, they have announced similar features for their future processor lines. Okay, so these features, the cloud is getting ready. Azure has Intel SGX and AMD SEV offerings. Google has AMD SEV, and AWS has something proprietary called Nitro enclaves. And these are sort of a hybrid between a secure enclave and a confidential VM. The only downside being that they don't have runtime encryption of memory. Okay, let's talk about use cases. What is this good for? And I think the first one here is a no-brainer: protection from the infrastructure, right? If I run my workload in a secure enclave, yep, I have great protection from the infrastructure in the cloud. The second big use case is that this allows us to create verifiable and privacy-preserving apps. This is an advanced use case that sort of builds up on the first use case. And this opens up great possibilities in a variety of sectors. And we have actually like 4 or 5 talks today that talk about advanced applications of confidential computing, for example, in the healthcare sector, in blockchain, or in AI. And just after my session today, Andreas Berg is going to give you an introduction to a large-scale enclave-based healthcare service that is just being rolled out in Germany nationwide. Okay, so now that we know what confidential computing is about, let's talk about where does this lead to. Can we just press a button and everything is confidential, or is there still some way to cover? And here I'd like to first give you a quote from the future. And let me read this for you. What we are heading towards is a fully confidential cloud. The infrastructure will be confidential. The services on top will be confidential. The records of what happens will be immutable and auditable and confidential. This is what Mark Rosinovich is going to say in about 2 hours. And I think this is a great vision. Like the entire cloud confidential, everything always verifiable. I couldn't agree more. I think this is absolutely where we must head as an industry and as a community. Another question, how will we get there? And by we, I mean, of course, community and industry. And let's take a look at the state of the cloud today. So let's consider a typical cloud native app. We have our Kubernetes. On that, we run some custom services. And then we have some managed services provided by the cloud provider that we use. And now the first step to secure this, to make this confidential, is, well, pretty simple. Turn on confidential VM features and run the services inside confidential context. Makes kind of sense, but if you think deeper about it, it is clear that there are still quite a few steps missing, right? Because if we don't verify the integrity of these containers, if they don't mutually authenticate each other, not much is gained. Some malicious actors in the infrastructure could still modify or eavesdrop on the connections between the services. Also, someone could mess with our Kubernetes controller. Someone could compromise the managed services. It's very difficult to really see how this could prevent any real-world attack, maybe aside from some exotic attacks like cold boot. So it's a step forward, but it's not really great. So what we want to get to is a state where we have our fully confidential Kubernetes with services, and everything is verifiable, and everything is secure and always confidential. Everything is talking to confidential services. And all of this, in the end, needs to be verifiable from the outside by the user. This is what we need to get to. And we will have a series of 3 talks on this track 1 after the first break, where, for example, the Cutter project will outline how we can get there. And yeah, I can highly recommend these talks. Now, what is missing? And I may be a bit opinionated here, but now I'd like to give you around 8 things that we as a community and industry are still missing until we can really say we have a fully confidential cloud. And let's start with a very simple thing. First, we need to get the foundations right. So kernel, bootloader, and everything else needs to be ready for confidential VMs. So we need to have the right features. That's the first thing. But we also need to harden these components because they've been written with, or they date back to like 30 years ago, 20 years ago. They haven't been designed with confidential computing style adversaries in mind. So we need to harden them for this context. And luckily, we have Jörg Rödel here today, and he's going to give us an update on the development in the Linux kernel. Second, we need proper remote attestation for confidential VMs. Essentially, every single bit that is measured in the attestation statement needs to be either user-controlled or open source. And we also have a talk on that from the Microsoft folks, and I'm really looking forward to that one. Third, we need this encryption that provides volume-level integrity, essentially that protects against active attackers and not just passive attackers, because this is what we need in a confidential context. We had a talk submitted for that. Unfortunately, it was withdrawn because the authors still need to figure some details out. Fourth, we need key management services with confidential features. So we need to be able to verify the key management services, and the key management services need to verify our confidential apps. Only then can we really have like large distributed, always on confidential applications. And yeah, 5, I think this is a no-brainer. Everyone would love to have confidential GPUs and AI accelerators, because this would open up a huge world of interesting large-scale applications. Unfortunately, we don't have a talk on that at OC3. Maybe next year. 6, meaningful remote attestation. As I said earlier, remote attestation is one of the key pillars of confidential computing. And we have 2 talks from Mike and Simon and Thomas that will touch on this. And let's think about what does meaningful attestation actually mean. And I think it can only mean like 2 things. First one is transparency logs. So we can't really expect users to verify attestation statements over large amounts of binary code, but instead we can provide transparency logs where we have an audit trail for the packages that are used in our confidential apps. And we'll have a talk on that from Project Oak later on. The second thing, attestation of semantics. Right? In the end, it's all about semantics, and how great would it be if we could attest to certain semantics. And we have a talk on that as well. And finally, this is a non-technical part, regulation and compliance. For most businesses, to derive value out of confidential computing, we would need regulation and industry guidelines and standards to include and recommend confidential computing. Only then we could get wide adoption for confidential computing. And I'm really happy that we have 2 talks on this, one on PCI compliance, and one on governance in the financial sector, and looking forward to that. All right, these were the sort of seven points that I think we need to tackle before we really can get to a place where we have a confidential cloud that's usable for everyone. And now let's think about what do we have already, or I would like to show you what we have already. And by we, I now mean Edgeless Systems. And here's our portfolio of open source tools. You may recognize that, and we have been building that for the last 2 years. And there will actually be 2 talks today that will leverage these tools to build scalable confidential apps on Kubernetes. And this is what our portfolio is all about, enabling people to build confidential apps on Intel SGX and scaling these on Kubernetes. And as I said, I would now like to announce the launch of our first commercial product. And this product is called Constellation. And we have been working on this for a year. We're super excited to tell the world about it today. And for Constellation, we essentially took all of our learnings from the right-hand side, like how to scale workloads on Kubernetes, how to mesh them securely, how to manage them, and we put it into an easy-to-use framework. And now for the first time, we're not using Intel SGX, but we're using AMD ACV and AWS Nitro enclaves as a foundation, and also Intel TDX in the future. And in a nutshell, Constellation gives you a fully isolated, confidential, and verifiable Kubernetes cluster in a cloud of your choice, where all the connections are end-to-end attested, end-to-end encrypted, and you can run your containers as you're used to. From the inside, everything looks and feels like normal Kubernetes, but from the outside, everything is strongly isolated from the infrastructure. And you can verify it you will get one concise attestation statement for your entire deployment. And my colleague Moritz will talk a bit more about the architecture on this track after the first break. Here's how easy it is to use. So it's a command line based tool from the user perspective, and there are 3 commands. First one is constellation create. This creates your confidential Kubernetes on a cloud of your choice. Second one is constellation init. This initializes your Kubernetes cluster. Then constellation verify verifies the attestation statement of the cluster. And after that, everything is already configured and you're ready to use kubectl or other Kubernetes frontends as normal. You can just drag and drop your existing containers, scale them up, scale them down, and everything will remain confidential and verifiable. So if you want to learn more about that, please head to our website or go to our booth. And I will also be at the booth in the first break to discuss this or other things. Yeah, looking very much forward to your feedback, and feel free to book a demo on our website if you're interested. All right, that was my session. And to summarize, I think we are now really at a tipping point where confidential computing is going mainstream. I think we're heading towards a place where everything is verifiable and encrypted, but there are still a few obstacles we need to overcome. And I think we'll learn about cool solutions to these obstacles today, and I can't wait for all the great discussions. Thank you and have a great OC3.